Hey guys, we are back with day 2 of arcs and chords. So we're going to pick up with things where we left off. I want you to keep in mind the 3 rules or properties when it comes to arcs and chords. 1, if 2 chords are the same distance from the center, then they are congruent. 2, if 2 chords are congruent, then their arcs are congruent. And 3, if a diameter or part of a diameter is perpendicular to the chord, it bisects the chord and its arc. That's going to be a big focus for today. So let's see what's going on. We're going to do a little bit of just mixture, and then we'll turn it our focus. So let's look at our first one here. We are given, let's see, what are we told here? BA is 30. So BA, the entire diameter is 30. Now, what does that really mean? Because it's made up of 2 radii. So this is, leading into a lot of today's discussion. That means we have 15 and 15 because the diameter is made up of 2 radii. DC, let's find DC. DC is 20. Notice that our diameter is perpendicular to the chord, so we bisected the chord, 10 and 10. And our question asks us to find DE, so we have it. It's 10. This question is purely based on yesterday's lesson, but it's a good lead-in to what we're going to have to do today. Maybe we have to cut the chord in half. Maybe we find half the chord and double it. Maybe we take the diameter and cut it in half for a radius. Maybe we find the radius and double it for a diameter. So it's a good connection to what we're talking about today. Let's look at the second example on this page, of this slide here. So we have BC. BC is 6x plus 4. And then we have DC. So DC right there is 4x plus 16. And, well, again, since the chords are equal distance to the center, you can notice in this picture that we are marked as congruent here. Since the chords are equal distance from the center, then those chords are congruent. So we have 6x plus 4 equals 4x plus 16. And of course, we can do some work from there. We've got a 2x and a 12, and x equals 6. And now we're asked to find AC. So we want to find AC right here, but we weren't given a formula for AC. We're going to have to find the whole thing, BC, and then just cut it in half. So we're going to find the entire chord, 6. So 36 plus 4 is 40, but we only wanted half of it. So AC equals 20. All right, we'll find the whole chord and cut it in half. Okay. Measurement of arc AB. Well, again, we're using our knowledge from yesterday. If the 3 chords are congruent, so look at our chords. If the 3 chords are congruent, then the arcs are congruent. So what do we really have here? We have a circle, 360, cut into 3. So that means the measurement of AB equals 120 degrees. If you think about it, this is an isosceles equilateral triangle, and an equilateral triangle has 60-degree angles. Since the angle is on the circle, angle equals half of its arc. So we can do this a few different ways. Now let's transition that into today's work. Looking at the next question, I'm just going to blow this up a little bit. So let's see what we have. DC is 24. But I want you to notice BE right here, that's a part of a radius or a part of a diameter. Since it's perpendicular, it bisects the chord. So the whole chord is 24, but this piece is 12 and this piece is 12. BE, we were told, is 9. And now we're asked to find the radius. So the one thing I want to do first is draw the radius. I want to be able to see it. So I could draw that radius wherever I want. But that radius that I just drew, it really didn't help. So let's draw the radius in a place where it actually helps and it closes off the right triangle. Remember, in yesterday's notes, I told you there's 3 parts to the triangle. There's 3 sides. One is the distance from the center to the chord. The other one is the chord, or more specifically, half the chord. And the third side that closes it off is the radius. The nice thing here is that we can take that radius and draw it wherever we want. All radii of the circle are congruent. So instead of BD, I could have drawn BC. It doesn't matter because all radii of the circle are congruent. So I can draw it wherever I want. Now, what do we have? We have a right triangle, and we know 2 out of the 3 sides. Well, there we go. That's called Pythagorean theorem for us. So we're going to do 9 squared plus 12 squared equals the radius squared. All right, so let's work it out. We have 81, 144. We're going to grab our calculators. So 81 plus 144 is 225, and that equals r squared. Well, we don't want r squared, we want r. So we're going to take the square root, and r equals 15. All right, so we can draw that in wherever we need to. Now the question could ask for diameter. Well, if the radius is 15, the diameter is 30. So we're going to figure out how to label that triangle, and then we can figure out anything we want. Let's take a look at this one. This looks like it's so much more complex, but it really isn't. Let's look at the important parts here in this picture. Always find your right triangle. So what do we have going on here? We know this side is 5.1. We know this side is 9.7. And the reality is we know that this side is 8.2, right? Because the radius is perpendicular, so it bisected the chord. So we know everything about that right triangle. So we understand the picture. Now let's figure out what we actually have to do, because we were asked to find x, right? We were asked to find x, which is this segment out here. It is not the radius. Nothing says that we bisected the radius. That is not one of our rules. But let's look at our picture carefully. It is part of the radius. And how long is the radius? Well, all the radii are 9.7. So let's just pull this over to the side. If this segment is 9.7, and we know this part right here is 5.1, and we're looking for the rest of it, that's our picture. So our math here is pretty simple. 9.7 minus 5.1, and we get 4.6 for x. But we have to see that in the picture. 5.1 and the x together make the radius, and we already know the radius from a different part of the picture. Looking at this one, Again, we're using elements of the previous question in our thought process. In this problem, we're looking for x. That is the radius, and it is part of this right triangle. So we're looking for x. We already know 4.3. And remember, we already know this side also, because here we have a part of a radius, so it bisects the chord. So there's the three parts of our triangle. All we're going to do is a little Pythagorean theorem. So we have 4.3 squared plus 10.6 squared, and that equals the radius, or x, squared. So you're going to want your calculators handy here. So 4.3 squared is 18.49. 10.6 squared is, sorry about that, lost my pen, hold on. Sorry. $112.36. Having some pen issues. So we're going to take our 112.36, add 18.49. That gives us 130.85. Let me see if I can fix that. 130.85 equals x squared. And now, of course, we want to square root it. So we're going to do that. We're going to take the square root of both sides, and we're going to get x equals 11.438. And depending on directions and rounding, we might just go with 11.4. So it just does depend on rounding. So we found the radius. Again, keep in mind, they could have asked for the diameter. So find the radius and then double it. It just depends on the question. Okay. Let's see what else we have here. All right. Very similar question. We're just looking for the other side of the triangle. So I'm going to leave that one for you. In the bottom question, we'll blow it up. Think about what we're going to do here. We're going to combine the last two that we thought about, that we went through. So the first thing we're going to have to do is close off that triangle. And all we're going to do, that's a radius. So it's the same as the other radius. We don't need this one now, 18.9. We just spin it around to close the triangle. Now we can do some Pythagorean theorem and find the missing side of the triangle. Now, that's not what they asked for, but that means that there's more than one step, guys. That's really all that matters. So, do Pythagorean theorem. You guys know how to do that, so I'm going to let you do that. And as a result, let's see, 18.9 squared minus 15.7 squared. it looks like we get 10.5. But again, now this looks just like a previous question, because check it out. We know the entire radius is 18.9. We know the one piece is 10.5. But what we really want is that leftover piece. So we're going to take the entire radius minus the 10.5. And we're going to get 8.4. So this is combining two previous questions. Pythagorean theorem to find the side of the triangle. And then that is part of the radius. We're looking for the other part. So we had to subtract. So we are going to take a look at two more quick questions. And in these questions, the whole issue is that we have to draw the picture ourselves. So that's really the challenge. In a circle, so draw a circle, and I'm just going to indicate where the center is. And remember the three parts of the triangle: the chord, the distance from the center to the chord, and then the radius. I would draw them in that order. So the first thing I'm going to draw, for me, a chord. I'm sorry. Hold on, back up. Yes, I'm sorry. The chord is 10 units from the center. So I have a chord from the center is 10. Now remember, that's automatically perpendicular. Now I'm going to draw the radius because I want the radius to close the circle. So I'm going to save that for last. The only thing I can do here is Pythagorean theorem to find the missing side of that chord, of that triangle. So this is what we're going to do right here. So we have 30 squared minus 10 squared. And we're going to take the square root of that, 28.3. That's the side of the triangle. But look at the question. Length of the chord. So we're going to have to take our 28.3 and we're going to double it to get the entire chord. So 28.3 times 2 is going to give us 56.6. Keep in mind, all chords have to be shorter than the diameter. The diameter is the longest chord, and in this question, the diameter is 60. So that's a good kind of gauge. Make sure that your numbers make sense. If our radius is 30, then the diameter is 60. This chord was 56.6. Long as it's smaller, it has a chance. So draw these carefully and make sure that you label things as you go. Let's look at the last one. We have a circle. There's its center. So now we're going to go piece by piece here. A chord that's 20. So a chord that's 20. And I'm gonna blow this up and try to be a little bit neater there for you. So a chord is 20. That chord, 5 from the center. So from the center to the chord is 5, and we always make that perpendicular. Now keep in mind, as soon as we're perpendicular, the radius is perpendicular to the chord, we bisected the chord into 10 and 10. So the 20 really doesn't matter anymore. And finally, we're asked to find the radius. I'm always going to draw that last. It's just easier for me. There's my radius. And we have a nice little right triangle. So it looks like we're going to do Pythagorean theorem. 5 squared plus 10 squared equals r squared. So what do we have here? 125 equals r squared. And we're just going to take the square root of that and round to whatever they told us to. So when in doubt, we can say tenths is a fair place to go. So we're going to take the square root of 125 to the tenths, and we're going to get 11.2 for the radius. Okay, so again, we're just doing Pythagorean theorem. There's a chance that we have to do some trigonometry, so have your equations available, your formula sheet, but it's happening inside of the circle. We're using the properties of the circle, the radius, the chord being bisected, the distance from the center to the chord, which is really a part of the radius, to figure out the three sides of the triangle. Okay? This one's going to take a little practice, guys. Work on it. Let's see how you do. Look for a post from me a little bit later and get some practice with this. All right, guys. Talk to you all very soon.